Life with David. I'm David, and today I have a broken LED button light. I installed these lights about 4 years ago, and this one stopped working recently. I purchased a new one and replaced it, but I'm wondering if I can repair this one to keep as a spare. So why don't you join me in learning more about these LED button lights? I'd like to spend a moment on safety. There's nothing more important than keeping you and your loved ones safe. Be sure to read, understand, and follow the safety rules for your tools and electronic gear. Using your tools properly will greatly reduce the risk of personal injury. And always use the appropriate eye, hearing, and respiratory personal protective equipment. Although these lights are low voltage, the power supply is connected to the mains. Don't work on these if you don't understand or feel comfortable working around line voltages. Now let's get started. This is a WAC 87 round button light and is dimmable when used with a WAC electronic 24 volt power supplies. It appears to be a very solid unit. The case opens by removing 2 screws from the back. When separating the case, be careful not to lose the 2 springs that hold the glass lens tight to the front bezel. Inside we see the light module, which is secured to the case with 3 small screws. The light module is thermally coupled to the outer case using thermal grease. Let's examine the board more carefully. A digital microscope makes it much easier to read the numbers of the components and look for any obvious problems. I think this is a good place to start looking for problems. The component is labeled F1. I'll bet it's a fuse. Looking closer, it looks a little discolored. In fact, I think I see a little crack. Let's check it for continuity. Now open circuit, I guess it's shot. So the fuse opened up. I guess that means something else is wrong. I'll trace the circuit out so I can develop a schematic for troubleshooting. To speed things up, I'll pause the video and get back to you when I'm done. This took a little longer than I thought. During the circuit tracing, I found out that all of the 12 LEDs are okay. They dimly lit while I was using my ohm meter. The main chip is the PT4115 LED controller chip. It converts the signal from the power supply into a pulse width modulation current to the LEDs. We'll look at the signal from the power supply in just a couple minutes. There are also several capacitors, resistors, and diodes on this board. Let's examine the schematic more closely. The first element in the LED module is the fuse that blew. After the fuse, the AC voltage from the power supply is rectified by a full wave bridge rectifier shown here on the board. It is filtered with a 30 microfarad capacitor C1. The current then flows through a current sensing resistor network where the PT4115 gets feedback about the status of the LED network. The current then enters the anode end of two parallel strings of 6 LEDs each. The cathode end of the LED network is controlled by the PT4115 chip. The SW pin is a drain that is protected from the voltage spikes of the LED array by an inductor and a Schottky diode. The PT4115 chip uses a high-frequency signal from the DIM terminal to control the brightness of the LEDs. Let's take a look at where that comes from. A 4-wire Lutron dimmer is used to generate a stable supply to the WAC electronic power supply. The output is a 30 kHz burst that forms a 120 Hz high-level signal. As you can see, the duty cycle of the 120 Hz signal varies with the dimmer setting, while the frequency and duty cycle of the 30 kHz signal does not vary. The first thing in determining if this can be repaired is to see if I can get parts. The first part I know I need is the fuse. Since it has an 85 degrees C temperature rating on the silk screen, I'm assuming, either rightly or wrongly, that the fuse is a 5.1 ohm fusible resistor. The size is 50 millimeters by 25 millimeters. I can find 5.1 ohm resistors in that size, but they are not fusible and they have a much higher temperature rating. This could lead to the button light overheating and causing a fire. I can order 5.1 ohm fusible resistors, but I have to buy 10,000 of them at a much higher price than the $42 cost of the button light. Since this is going in the kitchen cabinet and will be unattended most of the time, I will not sacrifice safety for the sake of saving a few dollars. So prudently, I'm not going to attempt a repair on this button light. Thank you for joining me today. I was disappointed that we weren't able to repair this light module today, but we did learn a bit more about LED lighting and how light modules work. If you like this video, please give it a thumbs up. If not, give it a thumbs down. And leave a comment or suggestion for things to do. I hope to have more of these videos, so please subscribe and click on the bell for notifications of new videos. Let's get together next time for another day in Life with David. See you soon.